So today we are going to solve this problem, continuous subarray sum 5 to 3. So they are given nums of array and k. So what this problem asks is there a subarray whose sum is divisible by k. So see, but wait, let me tell you. So condition 1 is there are two condition. Okay, so condition 1 is, so subarray sum must be divisible by k only. Okay, and second condition is subarray must have at least two elements. Okay, so now what is subarray? Subarray is continuous part of array. We have this array, so let's start. 23 one element, 23 and 2 element, 2 and 4 2 element, 23 2 4 3 element, 2 4 6 7 4 element. Okay, now what is divisible by k? So see, divisible means remainder is 0. Okay, remainder is 0. So if 12 divided by 6 is 2 remainder 0 divisible. Okay, and 6 divided by 6 1 remainder 0 divisible. 7 divided by 6 1 remainder and 1 not is divisible. Okay, 1 is not divisible. So let's see, let's take this example only. Now let's take subarray of let's take this the elements. Okay, so 23 plus 2 plus 4 is 23 25 29. Okay, so 29 is divided by 6, so it's a 4 and remainder is 5, so 5 is not a divisible. Okay, now let's take subarray of 2 and 4. Okay, 2 and 4, so 2 plus 4 is 6 is divided by 6 1 and the remainder is 0, so at least there are 2 elements. Okay, so answer is true. Now let's take another example. If we have like nums of array like 23 2 6 4 7 and k is 6, so let's check. 23 2 6 4 7, 23 plus 2 plus 6 plus 4 plus 7 is 23 4 6 7 4 7, it was 42 and 42 is divided by 6, 42 is divided by 6, it was 7 and the remainder is 0. Okay, so there are 5 elements, so the answer is true. At least there are 2 elements also. Okay, so that if we here there are 5 elements, so the answer is true. Okay, now let's take another example. This only, let's take n is equal to 23 2 6 4 7 and k is 13. Okay, no subarray sum is divisible by k. Okay, 13, so the answer is false. So see, so what is the problem has given nums array of number and k is divisible. Okay, divisor, and we have to find is there a subarray of at least 2 elements. There was at least 2 element. Okay, so whose sum is divisible by k, and we have to return true or false. 1 or 0, true or false. So let's understand clearly. So see, you and your friends are collecting monies. Okay, you and your friends are collecting money. So person 1, they have 23, second person have 2, and person 3 they have 4, and person 4 6, and 5 person 5 7 rupees. Okay, and the k is 6. So now what is the question. So see, can we find a group? Can we find a group? So of continuous friends whose total money is exactly divisible by k. Okay, we want a group who's divisible by k. So at least we want two friends. So in group 1, person 1 and 2, let's take person 1 and person 2. 23 plus 2, it was 25. So 25 is divided by 6 full, so the remainder is 1, so not divisible. Okay, now in group 2 we take person 2 and person 3. 2 plus 4, 6, so 6 is divided by 6, 1, and the remainder is 0, so it was divisible, two friends. So the answer is true. So the answer is true. So why at least 2? Because the problem says a group of friends, you cannot have a group of just one person. Okay, problem has says group of friends, you cannot just group one friend, one person. So now what is divisible? See, divisible by 6 means when you share money equally among 6 people, no money is left over. Okay, 6 is divided by 6, 1 each, so no leftover. Okay, is 12 is divided by 6, 2 each, so no leftover. And 7 is divided by 6, 1 each leftover. Okay, so that's it. Now let's take one more example. See, we have, let's take small example, 1 2 3 and the k is 5. So now we check group of two friends. Okay, so the first we take 1 and 2. 1 plus 2, it was 3, so 5 is divided by 1 plus 3, 5. 5 is divided by 5, 1, and the remainder is 0, so two friends, so the answer is true. Okay, now see, let's take one more example. 1 2 1 and the k is 5. Okay, now check all groups. 1 2 3, it was not divisible, and 2 1 3, it also not divisible, and 1 2 1 4, not divisible, so the answer is false. So the answer is false. So see, they are given nums. Okay, money each person has, okay, and k is divisible by this, divided by this. So the question is, can we find consecutive people, at least two, whose total money divides by evenly by k? Yes means return false, no means return true. Yes means return true and no means return false. Okay, wait, let's take this. Nums is equal to 23, 2, 4, 6, 7 and k is 6. So 2 23 and 2 25 is divided by 6, it was 1, it was false. Okay, 2 4 29 divided by 6, 5, it was also false. 23 2 4 6 35 is divided by 6, 35 5, so the answer is false. 2 4 is 6 divided by 6, 0, so we have found 0, it was true. Okay, so see, this is brute force. Okay, so this is simple approach. See, we are trying every possible subarray, okay, of at least two elements. At least two elements, check if sum is divisible by k. So but this is slow because it is bigger of n square. So now the optimal approach is, see, remember prefix sum from LeetCode problem 303 we have done last time, so we can use same idea here also. Okay, so prefix of I is equal to sum from index 0 to I. Okay, so let's take sum of everyone. Wait, nums is equal to 23, 2, 4, 6 and 7. Prefix of all of this is 23, 25, 29 and 35, 42. Okay, so the sum of subarray of I to j, sum is equal to prefix of j minus prefix of I minus 1. Okay, so the c, when is number is divisible by k, so when remainder is 0, so sum is divided modulo by k is 0. Okay, so we need prefix of j minus prefix of I minus 1 modulo by k equal to 0. So this means prefix of j is modulo by k is, and prefix of I minus 1 modulo by k. Okay, so same reminder. Now let's try that. See, we have nums of array like 23, 2, 4, 6, 7 and k is 6. So the prefix sum of all the running sum is 23, 25, 29, 35 and 42. Okay, so see, remainder when divided by 6. So first take 23 is divided by 6 is 5 and 25 is divided by 6 is 1 and modulo by 6. Remainder when divided by 6. Okay, 29 divided, say 5 is same as index 0. Okay, so 35 divided by 6 is 5 and 42 divided by 6 is 0. So prefix of 0 divided by 6 is 5 and prefix of 2 5. Okay, so same reminder. So sum from index 1 to index 2 is divisible by 6. 2 plus 4 is 6, so 6 divided by 6 is 0. So step C, we are going to use HashMap, store reminder in HashMap. So key is reminder and value is index. Okay, so when same reminder appears again, check if subarray has 2 plus element. If yes, return true. So the important special case is, see, what if prefix sum is itself is divisible by k. Say prefix of j is modulo by k is 0. Modulo by k is 0. Wait. Okay, k is 0. So this means from some index 0 to index j is divisible. So we handle this by storing 0 is to negative 1. So in HashMap initially. So see, next is, so the idea is we create HashMap, okay, and store initially, and next step is we calculate prefix sum one by one, and next is we find remainder is equal to prefix of k, and next is we check HashMap. If remainder exceed, check if 2 elements, if yes, return true, if not, store remainder in HashMap. Okay, so this idea is false because in brute force we try every subarray. In HashMap approach we just pass one. Okay, now let's take a try then. Answer is equal to 23, 2, 4, 6, 7 and k is 6. So step 1 is, see, we create HashMap. We are going to store in index negative 1. So prefix sum is 0. Okay, so see, why this 0 is -1. So if prefix sum itself is divisible by k, we need index -1 as reference. So see, this means subarray start from index 0. Now let's start working. See, index 0, 1, 2, 3, 4. So index 0 is 23. So prefix sum is 0 plus 23. So the remainder is 23 multiplied by 6. 5 is 5 in HashMap. 5 is in HashMap. 5 not in HashMap. Okay, so we store in HashMap. So how can we are going to store this? Like this, we're going to store 5 is equal to index 0. Okay, so index 1 value is 2. Okay, now index 1 value is 2. So prefix sum is 23. 23 plus 2 is equal to 5. So the remainder is 25 multiplied by 6. 1. Okay, so is 1 in HashMap? 1 is not found in HashMap, so we store it. Okay, 1 is at index 1. Now value index 2 value is 4. So see, index 2 and value is 4. So prefix sum 25 plus 4, 29. Remainder is 29 is multiplied by 6 is 5. So is 5 is 5 in HashMap. So HashMap there is a 5 in at index 0. Okay, so 5 is in HashMap, previous index 0. Check subarray length. So current sum index is 2 and previous index is 0. So we calculate length is equal to 2 minus 0 is 2. So 2 is greater than or equal to 2 here, so return true. Okay, so see, why did this work? Because remainder at index 0 5 and remainder at index 2 5. So see, at index 2 5. So sum from index 1 to 2, prefix of 2 minus prefix of sum is 0. 29 minus 23 is 6. So 6 is multiplied by 6 is 0. So it was divisible. Okay, so the answer is, so the subarray is 2 and 4, that was 6. Okay, now let's take another example. 24, 2, 3. Let's take another example. Okay, let's take this example. Equal to 23, 2, 6, 4, 7 and k is 6. Now see, we have HashMap 0 is equal to -1 and the prefix sum is 0. So index 0 value is 23, prefix sum is 23, remainder is 23 multiplied by 6, it was 5. So 5 is not in HashMap. So 5 is not in HashMap. So what we do, we store in HashMap. 5 it index 0. Okay, now I come 0, 1, 2, 3, 4. Now I come here. Okay, prefix sum is now 23 plus 2, 25. So 25 is multiplied by 6, 1. So 1 in HashMap, no, so we store 1 is to 1. Okay, and next is where next is index 2 and value is 6. So prefix sum is now 31. So remainder is 31 is multiplied by 6 is 1 in HashMap, Yes, so in previous index is 1, so length, we calculate length, 2 minus 1 is 1, so 1 is greater than or equal to 2, no, so not long enough, so we update hash map, no, so we keep old index, okay. So now index I comes here, in index 3 value is 4, so prefix sum is 35, reminder is 35 is multiplied by 6 5, so 5 in hash map, yes. So what we do, previous in index 0, okay, 5 is at index 0 in previous, so we calculate length is 3 minus 0 is 3, so 3 is less than or equal to 2, yes, so we return true, okay. So the answer is true. 2 plus 6 plus 4 is 12, so 12 is multiplied by 6 0, so subarray from index 1 to 3, okay, 1 to 3. Now we are going to return true. So see, 2 6, so prefix 1 hash marker 0 1 1 and prefix is 0, so the answer is true. And see, let's write down the code, okay. So see, these lines, we need a function that takes nums and k as input from return true or false, okay. Now see, we have to create hash map. Why? Because we need to store reminder, we have to create hash map, we need to store reminder, hash map stores and key is reminder, so value is index, okay. So see, hash map is 0 is to -1, we start from this. So why -1? If prefix sum itself divisible by k, subarray start from index 0, okay. Index 0 minus 1 is greater than or equal to 2, no. So wait, actually index is -1, so give length, okay. Now let's write on the code. UNORDERED unordered map and map, okay. So map of 0 is equal to -1, map of 0 is -1. Next is say prefix sum variables, so why we keep running total of all element, okay. So we start from 0. So say prefix sum 0, index 0 23, okay. 0 plus 23 is 23. Now index 1 prefix sum is 23 plus 2, 23 plus 2 it was 25, and index 2 prefix sum is 25 plus 4 29, okay. So we start from 0. Let's write in prefix sum is equal to 0, okay. Now see, so now we will need a row, so okay, wait for int I is equal to 0, I is less than nums dot size and I plus, okay. So why? See, we have to visit every element one by one, okay. So here we are visiting every element one by one, here our I is visiting every element one by one, so that's why we need this, okay. So next we have to calculate prefix sum. So why? Because keep adding elements to get running total. So see, I is equal to 0, prefix sum is 0 plus 23 is 23, I is equal to 1, prefix sum is 23 plus 2 25, and I is equal to 2, prefix sum is 25 plus 4 29, okay. We have to add, that's why we write prefix sum is equal to, we have to add now nums of I, okay. Next we have to find reminder. Okay, so we need reminder when divisible by k. So reminder is equal to prefix sum modulo by k. Okay, so see, I is equal to 0, 23 modulo by 6, that was 5, and I is equal to 125 modulo by 6, 1, and I is equal to 2, 29 modulo by 6, it was 5. Okay, now wait, int rem reminder is equal to prefix sum modulo by k. Okay, so next we have to check HashMap, because see, if reminder already exist, we have check if reminder is already exist. We found a subarray divisible by k. So but check length greater than or equal to 2. So see, if I is equal to 2, reminder is 5. 5 is in HashMap, yes, so previous index 0. So at index previous 0, so 2 is greater than or equal to 2, yes, so we return true. Okay, now we check in HashMap. If map.c4u and count rem, if I minus map of our reminder that is greater than or equal to 2, in this case you return true. Okay, so next we have to store in HashMap, because if reminder is not in HashMap, okay, not in HashMap, store it, but if already exist, do not upgrade, keep old index. So we went longest possible subarray, old index give bigger length, like this. See, old index give bigger length, I is equal to 0, 5, not in map, so we store in map. Okay, and I is equal to 1, that was 1, not in map, so we store in this also in map 1. I is equal to 2, 5 in map, so we do not update, we keep this only. Okay, now see, if map dot count our reminder, map reminder equal to I. Okay, so in last you have to return false. Return false if we loop through entire array and no subarray found, return false. Okay, return false. So first we have HashMap. First we have create a HashMap. Okay, initializing with -1, and next let me write for spelling prefix prefix sum. So the prefix sum is 0. Okay, that this is running sum, and next is loop through array. I press place and we add a current element. We add current element, and then we find reminder, remaindar, reminder, and next prefix of, let me update from here also, that modulo by k. Now we check in HashMap. If map.count reminder, reminder, okay, reminder, and if you have like 2, next we store if not exit. Okay, store if not exit. Here we check hash map. If it's not, we store in hash map. Okay, store if not exit. Next we return false. Let me complete this sentence. Command C. Reminder, prefix sum. It's work. Okay, see. Let's have a small trial. Okay, we have nums of array that was nums is equal to 23 2 4 6 7 0 1 2 3 4. Okay, and k is 6. So map 0 is to -1 and prefix sum is 0. Okay, now I is here at index 0. I is equal to 0 and the value is 23, so the prefix sum is 23. Okay, so the remainder is 5. 5 in map no, so we store 5. Okay, so we store 5. Let me write here 0 is to -1 and 5 is equal to 0. Okay, now I comes here. I is equal to 1, value is 2, so 23 plus 2 25. Now prefix sum is 25 and remainder is 1, so 1 in map no, so we store 1 also in map, it index 1. Okay, now the I is 2 at index 2. I is 2 and the value is 4. 25 plus 4 29. It's 29. Okay, so the remainder is 5. Remainder is 5. 29 remainder is 5, so 5 in map. Yes. Okay, so I minus map of 5 is 2 minus 0, that was 2, so 2 is greater than or equal to 2 here, so we return true. Okay, here we are going to return true. So the time complexity of this is big of n false and the space complexity is big of n also, because we hash map store n elements. Okay, hash map stores n elements. So that's it. So this is a full code.